Okay. Good day, everyone. Thank you to attend this session. My name is Rubin, and now I'm working for ARM. Today, I want to share a brief introduction about the situation of Kubernetes on ARM. It's the agenda of the presentation. There are 5 parts in this session. Firstly, I will introduce the background of Kubernetes, and then let's talk about the architecture and some detailed information. At the end, I will introduce the situation about Kubernetes on ARM, about what we have done and the next steps we need to do. Now, as we know that Kubernetes is become the default factory standard for PaaS domain. In this page, let me describe it in short. Basically, Kubernetes is a container platform, a microservice platform. It provides a container-centric orchestration to manage computing resources, networking resources, and storage infrastructure. Kubernetes can provide much of the simplicity of platform as a service and enables portability across infrastructure providers. Kubernetes was born at Google and based on Borg in about 16 years ago. And in 2014, Google announced it as an open source project. In about 3 years ago, this project was graduated from CNCF, and today the version is about 1.19. Kubernetes is always described as a container orchestration platform. So why do we need it to manage containers? Here, I have summarized a few advantages in this page. There are 6 points listed here. Firstly, Kubernetes can create a hardware layer abstraction for development teams. Your development teams can quickly and efficiently request the resources they need. If they need more resources to handle additional workloads, they can get those just as quickly as possible, since resources all come from an infrastructure shared across all your teams. The second one, it provides a way of life cycle management. Kubernetes can manage state, health, and life cycle of a typical container application. The third one, Kubernetes provides the interfaces for different hardware resources, such as computing, networking, and storage. 3 important interfaces in Kubernetes we should notice: CRI, CNI, and CSI. At present, the most popular interface can work well on ARM platform, such as Containerd, CRO, Calico, Flanner, and so on. The next one, we can manage sensitive data on Kubernetes. We can create sensitive data on different levels in our cluster, such as in cluster level, cluster configuration data is stored in the etcd. We can choose to enable encryption for the etcd data on the local storage of the Kubernetes master by enabling a key management service provider. And in application level, when we deploy the application, do not store confidential information in the configuration file, config maps, or scripts. Instead, please use Kubernetes secrets, such as an image pool secret for registry credentials. Also, we can scale the application in a simple way. When we scale an application, we can increase or decrease the number of replicas. Each replica of our application means a Kubernetes pod. At the last, Kubernetes provides lots of extensible and flexible APIs, such as CRD, such as operators. Regarding to CRD, there are some popular projects based on it, such as KubeVault, such as run dptk in Kubernetes. Here, this picture shows the architecture of Kubernetes cluster. The central component of Kubernetes is a cluster. A cluster is made up of many virtual or physical machines. There are two types of machines, master and nodes, and there are many pods running on each node, and the master communicates with nodes about when to create or destroy containers. Please see the left side of this picture. It's a Kubernetes master. The master is the control plane from which administrator and other users to manage the scheduling and the deployment of containers. A cluster will always have at least one master, but may have more masters depending on the cluster's configuration. Please see the right side of this picture. There are 3 nodes here. All nodes in Kubernetes cluster must be configured with a container runtime, which is typically Docker. We can also configure the secure container for a Kubernetes cluster, such as Kata and Google gvisor. Let's see the key modules in a typical Kubernetes cluster. In master side, there are 5 key modules: API server, etcd, control manager, scheduler, cloud controller manager. I will introduce them one by one. Regarding to etcd, it is a persistent and distributed key value database. The master stores the state and the configuration data for the whole cluster in etcd. You can run etcd on the Kubernetes master or in standalone configurations. About the API server, masters communicate with the rest of the cluster through the API server. For example, the API server makes sure that configurations in etcd match with the configurations of container deployed in the cluster. And the controller manager, it handles control loops that manage the state of the cluster by the API server. In general, deployments, replicas, and nodes have controls handled by this service. For example, the node controller is responsible for notice and responding when nodes go down. Regarding to the scheduler, node workloads in the cluster are tracked and managed by the scheduler. This service keeps track of the capacity and the resources of nodes and assigns work to nodes based on their capabilities. The cloud control manager is a Kubernetes control plane component that embeds cloud-specific control logic. The cloud control manager provides an abstraction layer between the APIs and the tools of a cloud provider. For example, AWS storage volumes or AWS load balance. Regarding to the nodes, there are 2 key modules in nodes. The first one is kubelet. Each node runs an agent process called a kubelet. It's responsible for managing the state of the nodes, such as starting, stopping, and maintaining containers based on instructions from the control plane. The third one is kubeproxy. The kubeproxy is a network proxy. It works as a load balance for Kubernetes services. At present, IP tables and IPVS mode works very well on ARM. This page shows the abstraction of hardware layer in Kubernetes. In production area, there are 4 kinds of hardware resources we should notice: computing, networking, storage, and other I/O devices, such as GPU, SRV, FPGA, and so on. In order to resolve the problems of hardware differences, Kubernetes uses interfaces and devices to manage different hardware. On ARM, regarding to computing resources, we can use Containerd, CRO, and Docker. About the networking, we can use Calico, Flannel. About the storage, we can use Rook. For deep ticket applications, we can use SRV plugin and Mata CNI on ARM. Okay, let's see some important key concepts in Kubernetes. In this presentation, I list a few important concepts. Let's see it one by one. The pod object is a fundamental block in Kubernetes, comprised of one or more containers, a shared networking layer, and a shared file system volumes. In a Kubernetes cluster, pod is a basic scheduling unit. Each pod is assigned a unique IP address. We can describe the desired state of the containers in a pod through a pod spec. These objects are passed to the kubelet through the API server. Deployment. A deployment is a YAML object that defines the pods and the number of container instances, called replicas. So, for example, if a node running a pod dies, the replica set will ensure that another pod is scheduled. Services. This concept is very important in production area. Basically, it's an abstract way to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP address and a single DNS name for a set of pods, and can load balance across them. Currently, there are 4 types of services in Kubernetes: class IP, node pod, load balancer, and external name. Currently, kubeproxy, Istio, and Envoy can work very well on ARM. The Kubernetes node autoscaler is very useful in production domain. When it's enabled and there are pending pods in the cluster, it will ask for new nodes. At this point, we can manually scale the nodes, or the node autoscaler provides a suggestion of a specific node setup. If there is someone listening to that suggestion, such as AWS, GCP, DigitalOcean, nodes will be added or removed. About the pod scaling, the HPA is a built-in Kubernetes feature. We can use it to scale the pods. Technically, the HPA is a Kubernetes controller that tracks and is configured by HPA resources. The HPA monitors one or more metrics about an application and modifies the number of replicas of this application to keep the metrics as close as possible to a specific target value. Another important feature in Kubernetes is that Kubernetes provides many extended features such as customer resource definition, operators, API extensions. The full name of CRD is customer resource definition. We can use it to extend Kubernetes capabilities by adding any kind of API object for our applications. At present, on ARM platform, we can use it in several projects, such as KubeVault, such as deploy DPK on Kubernetes. So finally, let's talk about the situation of Kubernetes on ARM platform. Please see the whole picture here. We have fully enabled the Kubernetes cluster on ARM. I list 10 rough stories in the right side of this picture, such as a data plane acceleration. We can deploy ARM DPK application by using Malta's CNI and SRV plugin. Regarding to CRD, we can use KubeVault to manage virtual machines on ARM. We can also use the popular plugins on ARM, such as CNI, CRI, and so on. Let's see the next page. Please see the 5 key modules in master and 2 key modules in node. At present, in the upstream, each module has the official release binary for ARM. These are good news for us. Let's see what we have done. I list several rough stories here. The first one is the official release for ARM platform. This job is done. Currently, both the development version and the stable version include the binaries for ARM platform. The second one is that we have enabled ARM conformance test, and this job is also done. Conformance test is very important for ARM. CNCF created test certified Kubernetes conformance program in Kubernetes version 1.7. Most of the leading vendors and the cloud computing providers have uploaded the conformance test report, such as Google, Amazon, Microsoft, and so on. For this story, we fix bugs to enable E2E test on ARM. Our internal CI system tests each release every day. Please see the right side as a reference. This is the upstream conformance test website, and this page shows the latest test result of ARM conformance jobs. For this job, we also enable the Sonobuoy on ARM. With Sonobuoy, we can simply test the conformance by using Sonobuoy binary on ARM. And at the bottom of this page, there is a link of our conformance jobs. We can easily view the latest test results through this page. The third story is multi-arc support for each plugins and interfaces. For now, Kubernetes is become a large ecosystem, such as CNI, CRI, load balancer, and device plugins. For this project, we have enabled several projects, as you see. Many patches were merged. For Kubernetes, we also enabled many related projects, such as node feature discovery. This project can detect hardware features available on each node and broadcast those features by using node labels. Also, we try to enable more Kubernetes-related projects for new domains, such as edge computing, such as automotive. For edge computing and automotive, we enable the KubeEdge and KubeVault. Currently, we can manage KVM virtual machines in Kubernetes on ARM. Also, we have the internal patches to manage Zen virtual machines on ARM. Okay, let's see our next plan for Kubernetes on ARM. I listed 2 stories here. The first one is that we are trying to enable ARM CI in upstream. And the second one is that, as we know, Kubernetes is become a large ecosystem. There are still a lot of jobs to do for multi-arc support, such as more CNI projects, more CSI features. Also, we should do more investigation in new domains, such as automotive, edge computing, IoT. As we all know that automotive is very important for our company, so this job should be a key task for us in the future. Thanks all.